Zambia recently sealed the debt restructuring deal with her bilateral creditors. As part of austerity measures, all cleaning companies in government health institutions have been directed by the secretary to the cabinet to employ hourly and salaried employees. The Human Resources Officer surveyed 108 employees about their satisfaction level with the current healthcare benefits program. The objective of the study was to establish whether pay type and level of satisfaction with healthcare benefits are related. So, colleagues, this statement here tells you you're dealing with a chi-square test of association. You're trying to see if two things are related. Okay, colleagues? A chi-square test just shows the relationship between two things or certain things. I won't just limit it to two, but it shows a relationship between two variables. Okay, two or more variables. And here, what we want to see if there's a relationship with pay type, level of of satisfaction, and the healthcare benefits. So, lucky enough, in this question, the tabulations have been done for you. Okay. Worst case scenarios where you have to do these tabulations by yourself. Yeesh, it's a long process. If they have to do it by yourself, okay. Let's start with part B. State the now and alternative hypothesis. Okay. So for chi-square, the now and alternative hypothesis is the now hypothesis. There is no significant relationship between pay type and the level of satisfaction with the current healthcare benefits program. The now hypothesis will always tell you there is no association or relationship. Okay, colleagues? Now hypothesis is always going to state there is no association or no relationship. Then the alternative hypothesis, which is the opposite, says there is a significant relationship between and level of satisfaction with the current healthcare benefits program. Are we okay with that? Part 2. State the following: the chi-square test statistic. Okay. Someone read this, they said the chi-square. No, not chi-square. The chi-square. Okay. So, have you seen this one? Pearson chi-square 2.666. This is your test statistic. Okay. It's your test statistic. Okay. The p-value, uh, I'm too fast. Yes. The chi-square test statistic, madam, is this 2.66 here. Okay. It's been calculated for you. Okay, just look for Pearson chi-square. Okay. Is that okay, Madam Geraldine? Okay. The p-value 0.264. The decision, yes, this one at asymptote significant two-sided. That's it. Won't write p-value, yes. They write them in codes to see if you are true, so that imposters don't do the job. Okay. 'Cause- Yeah, because someone who's trying to make quick money, they can say, "Yeah, I know statistics. I do everything." They give interpret this data here. Okay. They want to see if you truly know. 0.264. The decision, we can use the p-value rule to make the decision. Colleagues, what's the p-value rule? Okay. If you see this question, I would advise use the p-value rule. Okay. The other way you can get the decision is you get the critical value. But let's see, we don't have our confidence level. We do have our degree of freedom, but there's no confidence level. Okay. So our decision, we're going to use it using the p-value rule. Okay. The p-value rule is if your p-value is less than 0.0. Oh, let me just get some data, colleagues, before I get cut off. But the p-value rule, remember, if your p-value is less than 0.05, what do we do? That's how you get an A plus. Well, that's how you discover new things in researches and whatever. Einst- Einstein never used to sleep. Isaac Newton never used to sleep. Uh, Roger Phillips, the one who developed the Phillips curve, never used to sleep. Even these guys who did motivational theories, when in Maslow's, McGregor's, they never used to sleep. Okay. Mm, yes. So, colleagues, as I was saying, there's no confidence level here. Okay, so that you can get your critical value compared to the test statistic. Yeah. So I'm still here on the decision. Yes, it's either two ways you can get your decision with hypothesis tests. It's either you compare your test statistic with the critical value. Now, here we haven't been given our confidence level. We have our degree of freedom, everything else, but we haven't been given our confidence level to use the chi-square tables. Okay. So, the other way, apart from comparing the test statistic and the critical value, is you can use the p-value rule. Okay, and the p-value rule, if you remember from question one, if your p-value is less than 0.05, then there is a significance in the relationship. Okay, if your p-value is less than 0.05, then then basically your results are not by chance. So in this case, is our p-value less than 0.05? 0.26 is less than 0.05. It's less than, yes, it's less than 0.05. So we reject the null hypothesis. Okay. We reject the null hypothesis. Okay. So here you say on decision, we reject null hypothesis because the p-value is less than 0.05. That's what you write on decision. We reject the null hypothesis because our p-value is less than 0.05. Okay. We reject the null hypothesis. Okay. And what does the null hypothesis say? No, it says there is no relationship. Colleagues, because remember, part of your satisfaction at work is your the pay you get. Don't you think there's a relationship between how happy you are at work and your salary? So we take the null hypothesis because the p-value is less than 0.05. So our conclusion, there is an association or there is a relationship. What was our null hypothesis? Our alternative hypothesis. Okay. On the conclusion, you state your alternative hypothesis. There is a significant relationship. Okay. Between pay type and level of satisfaction with the current healthcare benefits. That is the conclusion. Okay. So remember, now hypothesis is always going to say there is no association. Okay. You see, you say chi-square. Now hypothesis will say there is no relationship. Okay. Then alternative hypothesis will state there is a relationship. Okay.